Just let the recording start once. Right. So hi guys. So today we are going to do the final session, and at the end of the session we'll give you guys a task. So it's not it's something like a programming assessment where you have to like bring in good ideas. We'll give you a task like this is what you have to accomplish, and you have to bring in like some. You have to think about it. You have to bring in a solution to that. So I'll just go over what all we had covered have covered so far. So we introduced you guys to the Ubuntu and Linux shell environment, and we introduce you to ROS and how what the architecture of ROS is, how it is made, how topics are made, how publishers and subscribers are made. So we all have you guys I hope have a fair bit of background with that with what we have conducted. So now what we're going to do today is that we are going to combine all of that what we have done, and we are going to make a drone fly from our code. And this is basically what this is a very large part of what we do at Aero Club, because when you can fly your drone with a particular piece of software, then you can your the number of things you can do with that is limitless. You have a lot of power then. So today we'll generate paths inside our Python script, and we'll make the drone fly in that path. And even the generation of these paths and everything is very interesting, as we have a very limited number of Mavros topics that that we can publish to. So, and let's say we want to make it go in a hard shape. So you'll be at a loss that how do I do this? Do I create every single point? What do I even do? How do I go forward? So we'll be giving you what we'll be doing here is basic, but we hope that if you guys show some decent interest in that, and you understand what it is coming out of, then you have a very powerful tool with you. And this is not just for drones. Like we'll be doing it for drones, but you guys can do it for anything basically. So maybe you want to simulate a car, you want to simulate a plane, you want to simulate anything, you can do that, and you can make good algorithms for their paths. So in like the last Mavros session, we discovered several Mavros publishers. So we'll mostly be using set point position and set point velocity. So I'll just go over what these were again. So set point position was when we feed the ROS thing, the topic of position, it will make the drone go towards that position. Set point velocity does the same thing with the velocity. So if we give it a certain velocity, and the way these okay, this one. Yeah, the way these velocities and positions are given is in a quaternion sort of orientation. So you have x, y, z, like vx, vy, vz, and omega x, omega y, omega z. So you have rotation, and you have linear motion in all directions, and yeah, so you have translation in all directions. So we'll be exploring these. We'll be making the drone do things, and okay, a little more background. So uh, one thing, so let's say you guys would have noticed Q ground control and everything. And if you went deeply inside Q ground control, you can see that we can give our drone a path right there. Right? We don't need a Python code to do it. But I'll tell you why we need a Python code to do it. So with Q ground control, you can give discrete points, right? You can tell it go to 1 comma 1 comma 0. You can tell it go to 1 comma 1800 comma 2, but there can be no feedback on this. Like you can only make it go in a position where you had planned before it took off, before the drone took off. So we'll be changing that dimension right now. So we'll have a code that takes live feedback from what is happening. And what is happening is the current position of the drone, that GPS global position or local position. We use local position, but in real life we use global position only. So we will have feedback from that local position, and the brilliant thing about that is that if we have feedback from a local position, then we can have feedback from many other things. So we can take feedback from a camera. So if you have camera, let's say you have a video feed, and if you're, some of you are into analytics and stuff, you would know of a library called OpenCV. And in that library, OpenCV, we can basically mess around with the pixels, with individual pixels in that, and you can make it follow. Like let's say there's a line of trees, you can make it go along that line. Let's say there's a mountain, you can make it go around the mountain. So you can do a lot of things. So today it's going to seem like a little underwhelming. What we'll do, we'll make the drone go in a line, we'll make it go in a circle. But from here on, like you are at a platform where you can do a lot more things. And yeah, in later sessions, like after summer school, post summer school, also we'll have some sessions. For project members, we'll have even more sessions. So we hope to, we will tell you how to go forward with this. We'll tell you how to integrate other sensors like cameras, lidar, everything, and then we'll have a more comprehensive sort of drone package built. So yeah, Pranit, you can take it off.
Yes, all right. So today we'll be covering, I think, two parts. One will be like a straight line, and one will be a circle. And like I'll be explaining you all the logic and all behind this. And after that, you'll be getting one assignment, which I think you'll have to do in, let's say, 2 or 3 days. And you'll have to create two additional parts, which we'll talk about later. Out of that, one is very easy, and one is like you'll have to think a bit. So I think we can start. So just let me present my screen. Yes. So earlier, like as we work with Q ground control, you all learned the plan and all the other things that we can do. Now we have the three codes, and I'll tell you why there are three, but actually these are only two parts. So first, I think we'll be going through how to make the drone motion linear. Also, like as a heads up, I already have raw score running, I have SITL running, I have gazebo environment running, I have Mavros running, and I have Q ground control running. So all the basic things that you need, I already have it running just to save time. So now we come to our first thing. What we'll do is we'll just take off, and till that time we'll see what all do we need for a straight line navigation. So what I'll do is I'll do a ROS topic list, like what all topics are running. And I think we did this in the last session also. So for linear, we just need to make its velocity to some constant, like let's say 1 or 2 or whatever. So we'll use the set point velocity in this topic. I'll just copy this, and we'll see the info on this. So I'll do a ROS topic info. Oh, yeah. So as you can see, the message type that is used is twist stamped. And so what you can do is you can see the message type from here, like what the message components are. Message show. Oh, again I forgot the message name. Yes. Okay, it should not write the geometry messages. Yeah. Okay. Spelling mistake. Yeah. So here you can see this is the header. We don't need the header right now. It is auto generated. Then we have a linear section and an angular section. And in linear you have XYZ, and angular also you have XYZ. So what we know till now is we'll be using the command, the topic this, and the topic type, the message type is twist stamped, and in the twist stamped you have all these things that are present. So moving on, so the code is not very different from the talker and listener. So I'll just give a run through. I have already written this just to save time in the session. And so let's make a function called linear, and linear will be when linear will be executed whenever we call this function. So your node, first thing is to initialize a node, and we'll name our node linear. Then we'll make a publishing object, And here, this is very important. We are not creating our own topic here. We are using an existing topic. And this is the existing topic that we'll be using. If you go on publisher, you can see the param name is name of a topic. So we are using this topic, which we saw in ROS topic in list. Next thing, the data class type, that is twist stamped, we saw when we did ROS topic info. So twist stamped is what we'll be using here, and queue size will be 10, right? So now we'll define a rate for our publishing. That will be 10 hertz right now, and then we'll make a velocity. Like we made a string in listener talker, right? That was called hello str. So that this will contain the message data. So it is like a message only, you can say. So it will be of the type twist stamped. So when you do this, the well, which is this object, will automatically have all the things that are listed. So the structure of well will be like this. So this is how well will look like now. Now let's set the velocity to 5. So the x direction of it should be 5. And now we want to publish this. So still raw score is running. We'll just publish this well using our publishing object, that is pub. And this already I explained to you. We'll just execute this function until ROS is interrupted or something. So that is how it works. I'll just quickly save it. I've already done catkin build and stuff, so you don't need to do it. But when you're making a new file, you should save this file, then you should make it executable, and then you should catkin build. Okay. So now this drone is there. It is already in air. So you just need to execute the command that you made. Oops. Execute the file that you made. So I'll just do a ROS run. My package name was navigation. I created a new one because there was some the data was corrupt in the old one. And you can use the beginner tutorials as well, no issues. And the file name was linear.py. Yeah. So now when you press enter, what should happen is, we'll just see. Yeah. So also the reason why this is going this side is in Gazebo, the environments are fixed. So this is your x-axis, this is your y-axis, and this is your z-axis. So that is why it's given x velocity in this direction. So now as you can see, it is going at the rate of 5. Okay, so just because we don't lose our drone, what I'll do is I'll change it to 1. And I'll rerun it. Yeah, now it's going a bit slower. You can see that in the Q ground control as well here. Now we need to see what is happening. So I'll just do a quick ROS RQT graph. So I'll just run a ROS run RQT underscore graph. RQT underscore graph. Yeah, I think this will take time to open because a lot of processes are going on. Yes. So now here. Now this is something, a Mavros thing that it uses to communicate. And see, now we made our topic linear, which is conveying the velocity through this set point velocity CMD well was the topic that we used, and it is giving it to Mavros. And then Mavros is responsible for controlling the drone. I think I'll just stop executing this because the drone will go too far. So I hope you got what I'm trying to tell you. So what happens, I'll just repeat it once. What happens is we make a node called linear, and we use this topic to convey or to control the drone. And to do that, we'll make a well, which is nothing but a message. We'll set the x component to 1. Also by default, everything is set to 0 when you do this. So when you set this to 1, everything else is 0. And then to publish this, you'll use a publishing object that you made, and you'll just publish your well message through this. And this will be automatically published to Mavros. So that is how this works. And now you can make any variation in this. You can use linear x to 1. Also, you can make like linear y to something. Let's make it 4, 3. Okay, and when you go back to terminal, where is
Change angular right hand.
okay, so okay, I think we didn't stop it. Yeah, okay, it's still going. Yeah. Now what I'll do is I'll rerun it. So it'll have x as 1 and y as 3, I think. Yeah. So as you can see now, this is going in a slightly diagonal direction. If you're thinking it's going in a linear direction, we'll just check the QGC. So here, as you can see, this x component of the velocity is 1 and y component of velocity is 3. So that is how this works. Now you might be wondering, like, we used QGC for that. So QGC, when you alter all the, like, let's say you make a waypoint and there are certain parameters of the drone about the maximum velocity it should go or something like that. So basically this is how QGC works. Like, it changes the drone parameters and uses the messages that are available to control the drone. So also, like, the drone is very far from the start point, so I'll just do a return to launch so that it gets into place. Yeah. So now, does anyone have anything to ask in this? Also, like, one more thing, we can use the Z as well to increase or decrease the height. So I'll just try to do that once. And linear Z should be, let's make it 4. So I'll just make this guided again because we need to execute one script. Yeah. So this is stopped now. Wait, is our node still running? Oh, this is still running. Yeah. So now it should become stationary after some time. Yeah. So now I put a Z component in that as well. And here the current altitude is 15 meter. So when you run this again, so as you can see, the altitude is now increasing at a very fast rate because it's 4. Yeah. So as you can see, the drone is moving up as well as it is going in a slant direction with respect, like, x1, y3 and z is 4. So that is also one way how you can control the height of the drone. Okay, I'll just stop this and let's return it to launch. Okay, so this was how you make a drone traverse in a circle, or sorry, in a straight line in XYZ direction. So does anyone have anything to ask regarding this? This was a pretty straightforward code. What you just need to change the XYZ component of the velocity, nothing else. So I think we'll wait for like 1 or 2 minutes. You can take a look at the code and try to understand it. And if you have any difficulty or anything to ask regarding it, so you can ask. All right. So since no one has anything, we'll do one thing. We'll do a circle code. So this is a circle code. No, nothing has changed. Only the thing we have changed is angular. We are putting it to 10, let's say. So what ideally should happen is it should go in X, and then because of its angular component, the face like the drone's orientation should change in the z-axis. So obviously it will change along the z-axis. So if you try to run this now, uh, just a second. Yeah. All right. So our drone is landing. We just put it to guided mode. Yeah. So we'll do one thing. We'll start executing the circle code. It's called circle.py. So you can notice one thing, that it has an angular velocity and it has a linear velocity as well, but it is not going in the circle. So this is one major mistake that people might make while implementing the code. So here the thing is, whenever you use this angular and linear, so the coordinate system is in respect to the gazebo environment. It is not in respect to the local drone. So even if for the drone, in that frame of reference, the axis is changing, but in the gazebo, x-axis is still this. So that's why you changing the linear and angular both won't help. Okay, so that is why this won't work. So instead of that, what we have is, we have created another code, which is a new circle.py, which is actually how it should go in a circle. I hope you got why this is wrong. You need to have something local coordinate system to the drone, and so if the coordinates are changing with respect to orientation of the drone, then this will work. But since it is not, so we, as everyone knows, the circle is given by a cos t and a cos t, a sin t. The parametric coordinates are the parametric velocities. So what we have here, we are doing, okay, now, okay, one more thing. We are using this outside the while loop, because these, even if we use it inside, the values are going to remain constant even here. Okay, so when we do, if you want to change the values continuously, you have to put it inside a while loop. So here what will happen is, just a second. Yeah. So now here what will happen is, the circle velocity is given by a cos t and a sin t, whatever. So when you, let's say t is equal to 0 for now, so it will go till this. Now since the rate of publishing is 10, and that will be, I think it will be too slow. So what I'll do, I'll make it 20 here, right? So yeah, so now we'll be able to publish message at a faster rate. Now here, yeah, so now what will happen, as soon as one while loop is over, we'll use time here. We'll not use anything, we'll use a time. So what, absolute time, like whatever time is it, you might know that the time is stored in a, like not the one that is shown on the clock, but it is stored like a hex variable. So it has a lot of digits, and that the unit is seconds, and then it's point millisecond something. So we'll use the absolute time, and as soon as one while loop is completed, when it enters the next while loop, it will change the thing to something, like it will change it according to the time. So let's say it was 0. Now after one while loop, it became 3 degrees. So it will go like this, then it will go like this, it will go like this. So that is how a circle will be made. So this is a proper logic on how to make a circle. And so, okay, one more thing, this has been done t by 4, because t would be too fast and the circles would be like really small. So I just changed the rate here, and I'm doing the, okay, and this is how you access like the absolute time. You import time here, and you do time dot time gives you the time, and the round function just rounds it off, because there are a lot of precision digits. We don't need that much, so time, it will just round off. Yeah. So moving on. Now we'll execute like a circle command. So ideally what should happen is it will go in any random angle, because the absolute time is not 0. So whatever the angle is, it will start moving in that, and it will make a circle, however. So yeah, so let's do a ROS run, navigation, and the script name was, I think, new circle.py. Alright, so you can see it has started some kind of motion, and I'll just open QGround control so that we'll be able to have a closer look. So as you can see, it is making a circle. It is trying to make a circle, and so this is how you make a circle. Now if you want to make the orientation of the drone also change with the circle, so you can add an angular component in the z direction, which will be matching the frequency of this. Okay, so that is how you will change the orientation of the drone along with the circle. So also, since we are doing this with velocity, to increase the radius, you can do is what you can do is just a second. Yeah, what you can do is you can increase this factor so that the time period will become more. And let's say you want to move in a fixed radius circle. Okay, so what do you think, like, would be the logic behind it? I want someone from the audience to answer. Let's say you want the circle to be in a fixed radius, and you want to use only the velocity. So according to you, what can we do? Any, like, try to think of it and you can answer. Right. So no problem. I'll tell you. So when you use this, okay, the circle which is made, the velocity is always 1, right? And when you do this, just a second, where is it? Sine t by 4. Okay. So when this becomes 2 pi, you you make one circle. So you basically, your time period for one circle will be, right now it is this. Okay. So let's say you want to make a circle of radius r. So in this time, you need to like have some velocity to be able to complete it here. So we can, what we can do is we can just add any constant here. Okay. So in this way you can add any constant, and that will you can change the velocity of the of moving. So if you want to make a particular like radius, you can calculate what this constant will be, so that the circle can complete in this time. So that is how you can use the radius factor also. Right. So this is like, and I think now we come to an end of what we had planned. Unfortunately, due to time constraints, we couldn't do the flight thing planned, but we'll arrange the session for it outside summer school. And this is I think we'll now conclude the summer school sessions in general. And so now we'll be talking about the attendance system and all for the certificate. So it has been decided that the attendance won't contribute that much on your certification, and to obtain a certificate, you'll have to, like, submitting the task is compulsory, and as well as, like, I think your attendance will also be taken into consideration. And also, since today I think most of the 21 batch people are like traveling, so that is why we don't have many attendees. So I don't think we'll consider attendance of today's session. But now coming to the task, what you need to do is you have to make uh, let's say you have to make 3 codes. One, you have to make a code of how to move a drone in a helix. Helix is nothing but like a small tornado with uniform this radius, like a DNA basically, but a single strand. Next thing you need to do is you need to find a way to navigate when you put a waypoint. So I'll be giving you the important topic for that, but you only need to use those two. I'll give you two topics. So you need to find a way to use those two topics and make, like, let's say you feed in some destination or something. So you should be able to go from your point to that destination. So that is your code. And using this, you'll have to make a code of how to move a drone in a square. Okay. So you can do now this square part will be your third task, and you can do it using this waypoint thing, or you can do it using your velocities thing. You have both options. Whichever you find easier, you can do it. And so that will be your task. I'll be making a Google form on how to submit, and you just need to submit this code. Just save it as Python files, and you can upload it. And or I'll give you a GitHub link. You can just put it on that. I'll be Yeah. So that is pretty much it. And I'll be also putting this task on the WhatsApp group. So yeah, so good to have all of you here, and it was fun experience for us teaching you, and I hope it was a fun experience for you learning as well. And now, as the summer school is ending, if you still have any doubt, you can ask. We won't be dissolving the group or something, and the resources will be always available to you. Akshat, would you like to add anything on, like, a conclusion note or something?
No, I think we are pretty much done for the most part. And yeah, good. It was nice to have you guys, especially those of you stuck around to the last session. But it's fine. You guys had other things to do. So yeah.
All right, guys. Then see you, and we'll have another session soon. So yeah, stay tuned. Bye bye.